Hey, what's up guys? I hope you are fine and doing well. So in this video we will see the PID controller for quadrotor trajectory tracking with or without wind gust. So here you can see that we have two types of trajectories. One is rectangle and second one is circle. And it is the outer loop of PID, it is the inner loop of PID controller. And here you can see the quadrotor dynamics, in which translational and rotational dynamics subsystems are present, and it is the rotational dynamics. So let's move to the code and see the results. Here you can see the MATLAB code for that Simulink file, and here is the system parameters, in which the gravitational acceleration, mass of quadrotor, moment arm, calibration constant, kf and km, and the inertia matrix are present. Here you can see that we have two scales for wind gust. We have turned on these scales because we are implementing it with wind. So scale 1 has the value 0.0001. You can adjust accordingly, and scale 2 has a value 0.001. And here you can see the shape. The shape is equal to 0 mean circular shape, and shape is equal to 1 mean rectangular shape. So let's run this for circular shape. Here you can see that here is the trajectory tracking of PID controller with wind, and it is somehow smooth, but with the wind it is some disturbance like this. And it is the reference trajectory of x, y and z as compared to the quadrotor trajectory. The comparison you can see here. So let's run this for rectangular shape. Shape is equal to 1 and run it again. So here you can see that as it is with the wind disturbance, so you can see that with the wind disturbance it has some disturbance or distortions here in the graph, and it is the x, y and z trajectories. So let's move to the second code, which is with no wind scale. Like we have turned off the wind gust of all two scales, and here let's run this for circular shape. Here you can see that how smoothly it is following the circular trajectory, because there is no disturbance present here. So it is working very well, and it is the x, y and z trajectories. So let's run for it rectangular trajectory. Run it again, and here you can see that the rectangular trajectory is also very smooth, because there is no wind gusts are present here. As you can see that it is the with wind gust results. When I zoom in, so you can see that it is the with wind gust results of rectangular and circular trajectories, and it is without wind gust. So obviously the without wind gust results are very smooth as compared to the with wind gust results. So it is the video. I hope you like this video. If you like, then please subscribe to my channel and share this video to your friends. Moreover, I am a mechatronics and control engineer, and I do projects for students and researchers. So if you need any assistance in your projects, then you can contact me. My email is given in the video and also in the description of this video. Thank you very much. Stay blessed.